And today is episode 22, and we're looking at high-rise sprinkler protection. So I'm going to start off with a few questions, which I'm then going to answer. So I think there's a word for that, isn't there, when people kind of ask questions and ask them themselves, but that's exactly what I'm going to be doing. So first question is, what is multi-story? I suppose that sounds quite easy. Is it basically anything other than one story? So is a two-story building multi-story? What about basement levels? Do they count with multi-story or not? What about mezzanine levels that are, maybe do they count as a separate level or not? And sometimes, buildings that are built on a slope, again, they might have funny shaped pieces, which do they count as extra stories or not? So yeah, multi-story, sounds like an easy thing to kind of define and state, and maybe it is, but yeah, say multi-story for me is anything other than a single story. But yeah, I guess there are some exceptions, say particularly with mezzanine levels, maybe you wouldn't count that. Next question is, what is high-rise? Now that is certainly a much more complicated question to answer. Obviously in the sprinkler industry, we do have a set answer, which I'll show you a little bit later on. But it really does depend on what you're doing, who you are, as to what high-rise kind of means for you or the industry that you work in. It'd be interesting to see, I think, if you stopped 100 people on the street and asked them, what their definition of high-rise was. You could have like a family fortunes affair, kind of guessing what the answers would be. I think that most people would picture, a kind of a tall office block, apartment building, something that is, let's say, at least 20 meters tall, probably a lot taller. They'd be thinking sort of skyscrapers rather than high rise, I think. But yeah, it does very much depend on what industry that you are in. Obviously, we are dealing with fire, and it's actually very interesting to talk to people that work in the fire and rescue service in terms of their definition of high rise. For them, it's a very sort of practical answer that they would give you based on the equipment that's available. So really, for them, it's about ladders. High rise is, we'll come on to this about, does high rise equal high risk? But really, high rise is all about getting people out of the building. Well, fire in general, isn't it? Is about protecting people from fire. So having nice thick walls, some passive fire protection, which is going to stop the fire from spreading, and then also about evacuating people out of the building. High rise, anything that really it is not safe to jump out the window, could then be considered high rise. So I live in a fairly standard, typical two-story detached house. I would not like to jump out of my bedroom window. I would do myself some damage, but obviously if my life depended on it in a fire, then that's exactly what I would do, and I would have a very good chance of surviving, with maybe a broken leg, a broken rib maybe, but I would probably be okay. If you live in a three-story house, again, you're going to jump out your bedroom window from the top floor. Your chances of survival are going to go down. Then you get to 4 stories, 5 stories, then you pretty much can't do that. So yeah, for the fire and rescue service and that kind of thing, for them it's about ladders. It's about actually evacuating people out of a building where they can no longer sort of get through on the stairs, etc. So yeah, for them it's about what equipment they've got, and it's about how long their ladders are, would determine whether something is high rise or not. Obviously, most people would reach for an answer in terms of meters. But then again, is it 11 meters? Is it 18 meters? Is it 30 meters? Is it 45 meters? It depends who you ask and which particular code standards you are looking at. Next question, does high rise equal high risk? To this, I would say, not necessarily. We want all buildings to be very safe, don't we? We want everything to be designed well, to say have good passive fire protection, active fire protection, where necessary, and good resources for evacuation. So high rise doesn't necessarily equal high risk, although as we just talked about, it just becomes more problematic. I think we can all agree that the safest building is all going to be single story, spread out over a large area with lots and lots of fire exits, all over the place. That for me would be a safe building in general. So yeah, high rise does create this additional problem that we can't just evacuate wherever we want to. We have to use some kind of staircase and then some kind of exit. But obviously there are lots of things we can do to make high rise safe. So yeah, I would suggest that a high rise building which has been designed well and installed well and maintained well may well be safer than a building that isn't high rise. It's a lot shorter, but it's not been designed well, it's not been run very well, things aren't being maintained, etc. So yeah, high rise doesn't necessarily equal high risk. Next question, are specific definitions important? Well, again, I would say yes and no. Again, in an ideal world, every single building would be taken completely on its own, with a fresh sheet of paper, and say, right, how can we make this building the safest possible? What things should we do for this specific building, this specific design, to get the safest thing that we can. But it is useful a lot of the time to have some sort of preset terms, some preset instructions, and preset definitions, because that helps to standardise things across the country. Because someone's idea of a safe building might differ from somebody else's, so it often helps to have, say, standard set procedures where it says, right, if the building is like this, do this. If it's like that, then do that. So yeah, specific definitions, they can be very useful, but yeah, not always. Okay, well, let's have a look then. So this is my area. Like I say, lots of other people will have different takes on high rise. But let's have a look in the sprinkler codes, the UK sprinkler codes. What do they say about high rise and multi-story and things like that? So first of all, BSEN 16925, so our European domestic and residential standard. That kind of makes it quite clear that it bows out at 18 metres. So BSEN 16925 says, yeah, you can use this standard up to 18 metres or 4 stories, I guess, whichever is the lower term. After that, we're done. This standard is no longer appropriate for any building more than 4 stories or greater than 18 metres in height. So, like I said, I'm not saying that the standard is saying that anything over 18 metres is high rise, but that's the limit that they have. That standard sort of chooses to say, right, that's a limit for us. BS 9251, Table 1, again, it's got a similar kind of table that you'd find in 16925. This one, again, it differs. So we have blocks of flats that are over 18 metres in height to be category 2 or category 3. So again, 18 metres is something of a kind of a magic number. So there is a change. Blocks of flats under 18 metres can be the lower hazard categories. Anything over 18 metres, then it has to be category 2 or category 3. And that really depends on whether we are sprinkler protecting the common areas or not. That's kind of a key aspect to deciding whether it's category 2 or category 3. And there is quite a big difference between 2 and 3 due to the duration of supply. It makes, say, a big difference. Again, BS 9251 in section 4.3 makes this very specific point about high rise. It says you can use table 1 up to 45 metres. Okay, so blocks of flats, anything between 18 and 45 metres are covered by BS 9251. If over 45 metres, it says consult with AHJs. That's authorities having jurisdiction. That's really like the stakeholders of the building, the people that are kind of involved in its planning and development. So that may be building control, it may well be consultants, it might be the Fire and Rescue Service, it might be national health trusts, it might be care home trusts, people that are involved in getting this sorted out. So they will discuss additional measures and or alternative standards. So they're leaving that a little bit vague, I suppose. Anything over 45 metres. They're not saying that you can't use 9251, but they're saying that you'd want to have a think about what additional measures you could put in place. Or say you might decide that an alternative standard is required. That alternative standard is very likely to be BSEN 12845, which is the commercial and industrial standard for sprinklers in the UK. In this standard, which is quite a bit thicker than the residential and domestic standards, we actually have a section on definitions. So that's made my life quite easy in terms of putting this presentation together, because I've just lifted the definitions out of the book. So a multi-storey building, as far as BSEN 12845 is concerned, is a building comprising of 2 or more stories above or below ground. So yeah, that's quite a nice definition, isn't it? If it's 2 or more, it's multi-storey, and it doesn't matter whether 1 or both of these stories is below ground. As long as it's got 2 stories or more, it is multi-storey. And then similarly, in that same kind of section, in definition sections, we have a high-rise system. So it says sprinkler systems in which the highest sprinkler is more than 45 metres above the lowest sprinkler or above the sprinkler pumps, whichever is the lower. Okay, so in very kind of in simple terms, anything over 45 metres, any building over 45 metres would be considered high rise as far as the sprinkler system goes. As you can see, there's a little bit of extra nuance there in terms of the height from the highest sprinkler to the lowest sprinkler, or looking at where the fire pumps are situated. And that obviously only comes into play where it's quite marginal, between the kind of 45 metres. But yeah, in basic terms, the magic number as far as 12845 is concerned is 45 metres. Anything over 45 metres is high rise. So that's what the UK sprinkler codes say. So what effect does this have? So yes, I've made a mistake there. The title should be Effect of High Rise under 9251. So this is 9251, where it is, you've kind of decided it is high rise, or it's over 45 metres, and that's where the statement says discuss additional measures and or alternative standards. So in the back of 9251, there is Annex B.3, additional performance, reliability and resilience measures. So these are the things that you will be discussing. Sat around a table with the AHJs, you will be discussing, first of all, are we going to use the standard, or are we going to use 12845? If we are going to use the standard, should we do the following things? And these are quite sensible. They're quite standard as far as other bits go. So increasing the duration of application. Okay, so as I say, category 3 under 9251 is 30 minutes. So we could increase that maybe to 60 minutes of supply. Upgrading the system to a higher category or to BSEN 12845, yes. Arrangements to maintain system integrity during maintenance or repair. That means that when we're doing sort of planned maintenance to the sprinkler system, can we actually keep it on whilst we're doing that? And again, those familiar with the 12845 will know what sorts of things we can do already. Provision of backup power supply to pump, yeah, so that in the event of a power supply failure, we've still got power to the pumps. Additional pumps to provide redundancy, so we might have 2 pumps, so if one fails, we've got a backup. Remote monitoring of critical system components, yeah, so actually got a panel somewhere which is having a look at the valves, the status of the fire pumps, monitoring the tank, high and low levels, the temperature, all of those kind of critical things we can be monitoring to make sure that they are ready to be used. Automatic test facilities are in there as an additional measure. So yeah, that may mean some of the products that the Project Fire sell. We sell automatic test facilities. Or it could be things that, for example, just run the pump a little bit every week or every 2 weeks just to keep it ticking over. Installation of a fire and rescue service inlet to supplement the water supply. Yeah, again, that can be an option. So those are the kind of things that you'd be talking about in, say, and that title number should be BS9251. So yeah, I've got these, by the way, I've got these the wrong way around, haven't I? So this title should say effective height rise under 12845. So yeah, apologies, I've got those round the wrong way. But at least I spotted it. So in 12845, we have Annex E, which is specifically the high-rise systems. So if you've got your building which falls under the high-rise definition, then you'll be turning to Annex E. And in here, it will say the following. Again, I've obviously summarised these, but yeah, you get the idea. So hazard class is limited to OH3. Okay, it makes sense. We're not allowed to have hazard stuff in a high rise, so we're not allowed to have, let's say a tyre factory that's also at high rise. That would be pretty crazy. So yeah, we're limited to OH3. And then, because of that, everything to do with OH3 shall be complied with in addition to Annex E. So, all of the other spacing requirements of pressures, flows, etc., everything else to do with OH3 should be covered with in addition to Annex E. Subdivided into installations so that no one installation exceeds 45 metres. We'll get onto that in the next few slides, but yeah, essentially we're going to split the building into 45-metre chunks. I won't go through the special rules regarding pipe work and static pressures. So this is the next one. Pressure may exceed 12 bar. Fittings and components should have a suitable pressure rating. So that's quite a necessary sort of get out of jail card. So the maximum working pressure of a sprinkler system is stated at 12 bar, but in high rise we are allowed to exceed that, and that's just because of practicality really. If we want to get pressure right to the top of our building, and we've got insulation control valves on the ground floor, then the pressure just is naturally going to exceed 12 bar. It may be something up to 20 bar, say, you might find on those sorts of things. So you just need to make sure that the fittings and components used are suitable for that kind of application. And then the water supply, superior water supply required, generally superior twin. And that's what we're going to be having a look at now is water supplies, high-rise water supplies. Okay, so on the left-hand side of the screen there, we can see this imaginary building, which is 120 metres tall, which has to be split into installations of maximum 45 metres. So you could have done it differently. Could have had loads of, could have had 4 installations of 30 metres, for example. But this example here is showing you a 45, and then a 45 and a 30. So one thing that I learned when I was speaking to fire pump manufacturers, say SPP in particular, I've been kind of chatting to, and they've helped me with some of these slides going forward. They refer to these as zones. And so they've got a 45-metre zone, another 45-metre zone, and then a 30 zone on top. Now, for me, that was quite confusing because a sprinkler zone is something completely different. So there'll be at least one zone per floor, if not 2 or 3 zones per floor. So yeah, I wouldn't call them zones, but just bear that in mind. You could call them stages as well, pump stages. But like I said, the 12845 refers to these as installations. So yeah, I would call them installation 1, 2, and 3. So the first thing that you can do, again, apologies, I noticed another mistake there. That should say option 1, separate pumps for each stage, all on the ground floor. So this is one way which you can set up your water supply for a high-rise system. You have a water storage tank, maybe in the basement, maybe outside, which has got the required capacity. And then you would have 3 pumps all on the ground floor, and pump 1 does stage 1, pump 2 does stage 2, and pump 3 does stage 3. So essentially, pump 1 is a smaller pump, pump 2 is a slightly bigger one, and pump 3 is a slightly bigger one than that. To give you the right pressure on each floor. Because remember, each sprinkler head has a minimum operating pressure, and we're going to lose pressure as the water travels through the pipe due to frictional loss, but most importantly for high rise, because of static loss, i.e. fighting against gravity. So our stage 3 pump has got to go all the way from the ground floor up to, I don't know, the 40th floor before it can then actually get to the sprinkler heads that it's serving. In which case that would need a more powerful pump to start at a higher pressure to actually then get a decent pressure once it gets up to the top. Option 2, separate pumps for each stage situated up the building. So instead of having 3 fire pumps on the ground floor, you could have your stage 1 pump on the ground floor, your stage 2 pump at the start of installation 2, so sort of halfway up the building, and then your stage 3 pump more towards the top of the building. The advantage of doing this is that each pump is essentially going to be a lower pump in terms of power, because each one doesn't have to overcome all of the static losses to get up the building, because they're kind of already in place. The disadvantages is that you've got to have separate water storage at each stage, and some kind of way of delivering water from one to the other. And also it's a nightmare for the kind of structural engineers, because you've got a very heavy water storage tank and a very heavy fire pump halfway up the building. They would prefer them all to be on the ground floor. Option 3 is an MSMO pump. And yeah, what is MSMO? That stands for multi-stage, multi-outlet fire pump. So you may have heard this kind of terminology. Some people, myself included, usually just call them a multi-stage pump. A multi-stage pump and a multi-stage, multi-outlet pump are actually different. Most of the time when we're talking about high-rise, we actually mean multi-stage, multi-outlet rather than just multi-stage, but I'd say we kind of shorten it slightly. So multi-stage, multi-outlet pumps are used when a single pump is needed to service multiple areas at different pressures, because that's like the problem, if you like. We need high pressure to get to the top. We don't really want high pressure to serve our lower levels, because the pressure is going to be too great. We have to then start installing pressure reducing valves. So we in the UK we prefer to use this multi-stage, multi-outlet arrangement. So how do multi-stage, multi-outlet pumps work? Well, first of all, let's look at the difference between a single stage pump and a multi-stage pump. So the picture on there just has a single pump. So we have suction, we have discharge. So the water is kind of drawn in, it's spun round by the impeller, and it's pushed out at a higher pressure. So you get one step, if you like. You get one go at increasing the pressure from the suction to the discharge. So once it's gone through that pump, that's it. You can't add additional pressure. It is what it is, and that's a single stage pump. So to create more pressure, we can actually add more impellers, and that will add pressure sequentially. It's a bit like building up speed. So when the water kind of spins round and gets pushed out, we can then actually collect that water, keep its momentum, spin it a bit more, and push it back out again. It's not quite like that, but that kind of helps maybe to understand what's happening about going through several layers of pumps. So it's a bit like this now. We've got 3 pumps here. So we're going suction, then discharge, into the next one and out, into the next one and out. And each pump is actually going to build additional pressure. But if you actually did what it showed there in the diagram, that's actually very inefficient way of doing that. You have losses in the interconnecting pipework, you have multiple motors and engines, and it takes up a lot of space. So this is generally not done in this way. So what can we do? Well, we can combine various impellers all into one casing. So that picture on the left there is a multi-stage pump. It's a multi-stage single outlet pump. Okay, so the water kind of comes in, it's got towards kind of coming into the screen, if you like, on this picture here. You can see part of the flange there which has been cut away. So the water will be coming in there, it spins through the first impeller, and then the second, and the third, and the fourth, and then there's 5 in total here, and it'll be out the distribution, the discharge pipe at a very high pressure. So this is really good because we're reducing the interconnecting pipework losses. We've got one common shaft, we've got one common engine, and it reduces the physical space required and of course also the cost. So this is a multi-stage pump, but we've only got one outlet. As I say, what we're looking for is to provide a higher pressure for the higher floors and a lower pressure for the lower floors, so that every head has got what it needs and not too much pressure. So again, what do? Well, we then have a multi-stage, multi-outlet pump, and there's a picture of one there in the top right-hand corner. So in this instance, yes, we've got a series of impellers, but the actual water can be discharged at certain points, at set points. So the water doesn't necessarily go through all the impellers before it is discharged. So that little graph there is quite handy. So that's showing a 5-stage, multi-stage, multi-outlet pump. So you can see the water can go through one impeller and then out, or 2 impellers and out, or 3 impellers and out, 4 impellers and out. And it's actually, again, it's quite clever because there aren't any sort of electronics sort of controlling this movement of water. It's simply that the sprinkler heads, let's say on level on the top floor, the sprinkler heads on the top floor discharge. There's a fire, the heads discharge water, that will cause a drop in pressure, which will then start the fire pump, and the fire pump will basically push the water out of the outlet which is requiring the water. So the water takes the path of least resistance. So that will want to fill up the insulation, which has lost the pressure due to the heads being discharged. So the water will come out of that final stage, that outlet. If the sprinkler head is on the lowest floor, then the fire pump will start, and it'll only go through the one impeller before coming out of the first outlet. So yeah, that is a multi-stage, multi-outlet pump, and as I say, that is what is generally preferred in the UK when we have high-rise buildings. So yeah, just again a reminder, just a thank you to SPP Fire Pumps, which helped me with those slides. Yeah, that they're one of the suppliers of multi-stage, multi-outlet pumps in the UK. So yeah, you can contact them if you want a bit more information or to get brochures, etc., about what they offer. So yeah, again, thanks for listening to that presentation. Next week, we're going to be looking at sprinkler testing and maintenance routine. We're going to be looking at what is required. There are lots of things required in terms of testing and maintenance on a weekly basis, on a monthly basis, on a quarterly basis, on a biannual basis, on a yearly basis, and then 3 years, 5 years, 10 years, 25 years. There's quite a lot to go through. Again, I'll have a look at how many slides that is. I may well split that into 2 different parts once again, depending on how much detail I kind of go into on each point. So yeah, hope you found that interesting. Once again, I will stick around just a few minutes to see if there's any questions in the chat. If it's questions about fire pumps, then yeah, I'll do my best. I might tell you to contact the fire pump manufacturers to ask those questions. All right, well, I hope you have a great rest of the day, and yeah, I'll see you next week, 10 o'clock, to talk about sprinkler testing and maintenance routines. All right, bye-bye.